and welcome everyone. So today what we're going to be doing is talking about how to graph, and not only graph, but how to graph and to create a line of best fit and to be able to get an equation from that line. And that way what we could do is we could say, okay, if I, instead of using 1 gram or 1.5 grams or 2 grams of baking soda, what if I used 6 grams of baking soda? How long should that take in order for my rocket to launch? Or I could even go the other direction and say, how many seconds would it be if I added 10 grams? How many seconds would I expect it to be? And so what we're going to do is we're going to create a graph that's going to be able to use that and that way we can answer some of those questions at the end of the lab as well. Okay, so what we're going to do is we're going to drag or copy and paste our data from table 3. Now you want to make sure that there are no letters inside of this bottom part right here, and it's all numbers. And don't forget that your choice number should be here and your average launch time should be in seconds, not in minutes. Okay, so I'm going to come right over to my graph here, and I'm going to paste in, I've made up some data, so I'm just going to Control V and I'm just going to paste in my data here. Okay, so there's my data. And now I have my set, and my choice was a 1.9, and it launched at about 5 seconds. Okay, again, I made this up. I just randomly threw in some numbers into here. And now what I'm going to do is I'm going to highlight this, and I'm going to click on the 3 dots because I don't see my graph icon, but now I can see it. It's this one with the bars on it, but we do not actually want a bar graph. So I'm going to click on this to insert the chart, and I do want a scatter chart. If it gives you something like a bar graph, we don't want that, like a column chart. So you're going to click on the chart type, and we do want a scatter chart. Okay, so once I get my scatter chart, I'm going to click on Customize. And now there are 3 things that we have to click. So everybody's going to repeat after me. Okay, so it's going to go Customize, Series. You're going to scroll down to the box that says Trend Line. Okay, so everybody say it with me. So you're going to say, I'm going to try to go back here again. So you're going to say Customize, Series, Trend Line. Everybody say it. Customize, Series, then you're going to go down and click Trend Line. After Trend Line, there's a label, and this label says None. I'm going to change my label from None to Use Equation. And what it will do, let me X out of this so you can see, once I click Use Equation, it's going to actually give me an equation over here for my line of best fit. So it gave me a line of best fit. This looks beautiful. What my expectation is that over, as I increase my mass, the time should go down. Why? Because the more concentration, then what did we say? What should be true of the reaction rate? Should it be faster or slower if I have more? It should be faster. Perfect. And so then my time should be decreasing. So if you saw that, that's awesome. So now what you're going to do is, once you click on the box, if you don't see the 3 dots, you need the 3 dots. So we're going to click on these little 3 dots right here, and I'm going to copy charts. And once I do this, I'm going to copy chart. I'm going to come back over to my doc and scroll down, and right here, it says copy and paste your graph here. So I'm just going to go right in this little green box and Control V, and we're going to paste that right in. Okay, once this graph is here, it says, what is your line of best fit equation? Now, this isn't in y equals mx plus b form. Well, it actually is. It just doesn't say y equals. So I'm going to copy this, which is negative 28.2x plus 55.4. And that is what goes right here. So that is negative 28 minus negative 28.2x plus 55.4. And that would be my equation. Okay, but yours is going to be different. Yours will not be the same as mine. So I'm actually going to use this here. So I'll show you in just a second what we're going to do with this. Okay, now we take a look at the questions on here. There are some questions into the conclusion. It's going to ask you to list some errors. Why could some of the things have gone wrong? But this question right here is the most confusing out of them. It says, use your equation of the best fit line to determine the exact mass of NaHCO3 that will launch in 8 seconds. And then it asks you to show your work, okay? So over here, I'm just going to show you real quick how we can solve this equation, okay? So what they gave us was time. Now I'm going to change the number. I'm not going to use the same number that you have, but let's say that I wanted to find out in 25, if I wanted my rocket to go off in 25 seconds, then how many grams do I need? Well, why did I put it there? My graph is time versus mass of my solid. And so time is on what axis? What do we call this axis? The y-axis. This is called the x-axis. So if I'm given time, time has to go in my y, okay? Then I'm going to solve for my x. So I'm going to say equals negative 28.2x plus 55.4. Now, this here is my set equation right now, but I want to solve for x and I want x alone. So remember, the beauty of algebra is what you do to one side, you must do to the other. So if I'm adding 55.4, now what do I do? Subtract 55.4. So I'm going to subtract 55.4 on both sides. And when I do that, so when I subtract it, I get negative 30.4 is equal to negative 28.2x. Again, I want x alone. It's not alone yet. If I'm multiplying by negative 28.2, what do I do? Divide by negative 28.2. And again, what you do to one side, you must do to the other side. And this should give me x alone. So if I divide that by negative 28.2, I get 1.08. And that would mean that's how many grams I should use based on my data. If I want it to go off in 25 seconds, then that's how I would actually work that out, okay? All right, I hope this was helpful to you. Happy day, everyone.